Idaho National Laboratory was formed in 1949 as a national reactor testing station. And it was here where Enrico Fermi's dream was realized and the first production of electricity from nuclear power occurred. Since that time, we've built 52 reactors on this site and established much of the design basis, not only for the current commercial reactor fleet, but for many advanced reactor designs. IMCL houses the same types of state-of-the-art equipment that you normally find at a top-tier university or a large industry innovation center. These tools and IMCL itself are configured specifically to handle high-activity radioactive materials to allow the characterization of these advanced materials. Most importantly, as a user facility, IMCL makes these tools accessible to nuclear researchers from around the nation and around the world.
So the main mission of the Irradiated Materials Characterization Lab is to answer the question of why certain processes are happening within nuclear materials. And we want to then couple those things that we find with the engineering scale changes within the material so we can readily answer the question as what things happen and why they happen. The importance of doing this work is really to develop a safer, better, more efficient nuclear system. And that all starts with the materials that you use for these systems. If we can really dive into why certain processes are happening within these fuels and materials, then we can seek to develop better, safer, more reliable materials to build more efficient nuclear reactors.
INL has extensive nuclear fuels and materials research and development programs. We first test our nuclear fuels in steady-state reactors to better understand the steady-state performance, and then also in transient reactors to understand failure mechanisms. We first characterize the fuels when they come out of the reactor on an engineering scale to determine critical performance parameters, and then if it failed, to determine the failure mechanism. The process starts when we manufacture a nuclear fuel here or bring fuel in from somewhere else. We then insert it in one of our reactors for irradiation testing. After irradiation, we bring it into the materials and fuels complex to characterize the fuel, first with non-destructive testing, then destructive testing, to understand both engineering scale and microstructural all the way down to atomistic effects.
Transmission electron microscope is an instrument allowing analysis, visualization of small sample from microscale to atomic scale. Transmission electron microscope allows us to study crystal structure, defects, grain orientation, chemical composition of phases in the material through electron diffraction, X-ray, electron energy analysis. Idaho National Lab has one of the best transmission electron microscope in the world. It's very unique and it's very productive.
So the work that we're doing for thermal properties actually comes in two different categories. We do thermodynamic properties and we do thermal transport properties. Thermodynamic properties are things like heat capacity and heat associated with microstructural changes in the material. Thermal transport properties are the efficient way that materials can move heat. And it's important because that is the property that determines how well a fuel performs in a reactor. And the design of new reactors and new fuels is based on that. What's unique about that is now we have the ability to measure thermal conductivity radially across the material, which is useful for how heat flows actually in the reactor. The third instrument that we have in IMCL is a thermogravimetric differential thermal scanning analyzer with a gas mass spec on it. It does thermodynamic properties and retained fission gas products.
At INL, we see a bright future for nuclear energy as a reliable, clean energy source that the world needs. So we'll keep investing in capabilities and infrastructure to allow nuclear development to happen in collaboration with researchers from around the country and around the world.